Hey everybody, and welcome to this segment of Inferential Statistics. This segment we're going to cover the ANOVA series of tests. So what we're going to do is we're going to introduce you to the one-way and the two-way ANOVAs, and I'm going to show you how they're different in a couple of different manners. The main difference between ANOVA and the t-test, as you can tell, both of which examine a dependent variable and then an independent variable. However, we got to look at the criteria for this one way for a second. It says can handle more than two groups of data. So when you look at the definition and it says one dependent and one independent, it could actually be more than one independent, but you got to see how they define it as one of those has to be nominal. So one of those has to be male or female. One of those has to be tall or small. So we got to have that type of, I guess it's a qualitative identifier to separate the two. Digging a little deeper into one-way ANOVA, here's table 5.6 from page 81, and before we get into the table, we're going to look at over here on the left-hand column. We're going to preface it some. So what we look for in this scenario or this type of test, you're looking at where it says the null hypothesis. It suggests that the mean of 1 is equal to the mean of 2 is equal to the mean of 3, or the alternative hypothesis, which suggests that the means do not equal each other. So that's just not in word sentence form. This abbreviated form. So let's talk about the situation here now. Let's address our attention back to table 5.6. The ID. Your ID on the left-hand column can be generally, you got to look at it as a number, but that's associated with a name or a person, some type of identifier. The groups, you see the groups are broken down into 1, 2s, and 3s, and then your 1 rep maxes. So you got your maxes, which have your numerical value there. The entire chart in ANOVA, you're looking at the table 5.6, and it's all numerical, but you asked, or I said earlier, that they have to have nominal classifications. So now we have to consider the fact that SPSS and Excel doesn't recognize words inside the cells when you click on these types of tests. So you have to correlate the nominative or the nominal means to a number. So you can see where I have groups, where it suggests that 1 is your free weight groups, the 2 is the machine populations, and 3 is your resistance band populations. So when we run the test, you can identify that this is one population here. Change color so it makes it a little easier. This is another population here. And then finally, you got your third population here, which is your resistant bands guys. So when you're trying to punch all this stuff in, you've used words and you hit calculate ANOVA and it comes up with an error. That's probably why you have to have numbers as opposed to the words or the classifications there. The systems only recognize numbers, so you got to do it that way. So we go through all the steps and we punch it into SPSS and we hit enter, and this is what it comes up with. So we have our 3 groups here: the free weights, the machines, and the elastic bands. And you can see the amount of participants that they have is 5 overall. We got 15. So what we do here is we look at the means, right? I'm going to circle a couple of things here, right? We got our groups, we got the amount of participants, which is even across the board, and we got our means. Right, this is what we all kind of want to look at. You can see that by interpreting this, you can see that the mean of the free weights was significantly higher than the machines and the elastic bands, and these are considered 1 rep maxes. So if you're training with elastic bands, trying to get that football combine, NFL combine quality of a bench press, you probably should rethink what you're doing. The rest of this stuff, it's good to know, good to have, but I'm not going to say we're going to ignore it, but we're not going to really talk much about this for a second. All right, so when we look at the ANOVAs, the results that we really want to see, right? The F-score, and you can tell it's a pretty decent size score there, so it's not like a 1 or a 2. which would, change the significance if that number was smaller. But also we want to look at the significance. So if you remember what the alpha level was, which is a 0.01, or 1%, you can see the results are significant here. So what are we doing? Are we accepting or rejecting the null hypothesis in this? So each of the tests provided a significant improvement, or you could actually interpret how the free weights had a significant improvement versus the other two modalities, which is where we have to reject the null hypothesis and accept the alternative hypothesis, as in the means of 1 does not equal the means of 2, which does not equal the means of 3. So let's take a second to familiarize yourself with some post hoc examination or test results. You can see in the top category free weights, the training method 1, training method 2, and 3. Free weights, the machines, and free weights to elastic bands. Basically, the free weights, had a marginal increase between both of those, your mean difference means. So they had a standard error which was equal. Their significance, right? What you have a 0.006. Don't let that get confused, because the alpha was 0.01, right? That means anything with another decimal point smaller. So that's a pretty significant increase. Then it has an almost absolute 0, which is that 0 significance here. That means absolute significance. But then again, just numbers to look at for oohs and ahs. Machines, right? Then you compare machines to free weights. Machines to free weights had a negative balance. Machines, again, had a 0.6 significance, and then from the significance comparing the machines to elastobands, had a your mean difference there, significance. Now this significance, right? This significance is above the 0.01, which means that's not a good one to go with. Then we look at the elastobands to free weights. The elastobands free weights was had a lower score of mean, or a lower mean score of 35.2 points, or however you want to, pounds maybe. Still the standard error applies all across the board, right? This comparison had a significant comparison, which is great, but then again we look at the elastobands to machines, which then again was lower in its results, which did not affect the standard deviation of error. And we go back to this number again, which we don't like because it was above the alpha level. So post hoc examination again helps rule into your interpretation. Do you accept the H1, or do you accept the H0? So, and the last test we're going to cover for inferential statistics is going to be the two-way ANOVA. I spent a little over 2 hours trying to figure out how to get the data to line up with Excel that comes out of the textbook. However, it didn't really work out that well for me. So there's a specific way that you have to code Excel, and I'm not that entirely familiar with how it works, but needless to say, I downloaded SPSS, and I'll do a tutorial based upon that here in a second. But let's go over what it is. It gives a score based on one dependent and 2 or more independent variables. And in the scenario provided by the textbook, you're going to look at the independent being the score from the coverages, and then the independent, the first variable is going to be the training methods, which is your scrimmaging and drills, and the other independent variable is going to be the positions, which is covered either between being a pitcher or having a fielder. Basically, you play the field, you're an outfielder or an infielder. So I'm going to call that fielders. So here's what it looks like when you open SPSS. I've made a few errors, as you could tell, with trying to make it look like it does in the book, but it doesn't exactly read that well. So what you want to do is you want to set up the variable tabs. You do that by going down here, and it's pretty straightforward. After you click on that, you pretty much name the tabs, the column tabs. So then you just fill it out, fill in the blanks as you see it in the textbook. So right around here is where the break is, and that this data fills up this way, but you want to move this data down here so SPSS can read the difference in methods and the difference in positions. All right, and here we are back to the data stuff. Here's what we're going to look at real quick. I'm going to highlight a couple of things. The first thing we want to look at is to make sure that all this lines up with the data that was given, which it does. The kind of look over here, you look at the means, gives you an idea of what you're about to either accept or reject, right? So when I say either accept or reject, I'm talking about the hypothesis. But over here, this is where we kind of get into the what we really need to talk about. So let's see what this button does. I really haven't used this one yet, so all right, excellent. Method, right? So let's look at method for a second. Since we want to talk about the differences between methods and positions, let's go over method real quick. So you can kind of look through the line here and you see method, but you see the F value, which is what you want to look at when you talk about an ANOVA score, is the F value. But then again, the significance as well. You see the significance is 0.256, right? And if you recall, our alpha is 0.05. So you see that means, you see this 2, that means that this number is higher in significance. So that means that if you were to accept the hypothesis based on the method alone, then that would be a null method or a null hypothesis that would have to be accepting, because you're accepting that there is no difference between both the positions and the drills that have to do with improving player scores or players' potentiation for playing the sport. Vice versa, let's look at the position, right? We'll come over here and we'll highlight the position, and I'm using a mouse, that's why it's not a straight line. And again, you can see the significance value is even higher than just the method alone. So you can see that the F value has gone down, which is kind of not that great either. You got to look at the F value as like your Z-score. So when it's smaller, that means it's closer to the mean or the average or the middle portion of the normal distribution. The bigger the number, the further out to the tails it's going to be. But the significance again is a lot higher than what we were hoping for. So let me erase this for a second. We'll recircle it just so I can see the next number. Ooh, I did it again. Oops, I did it again. Let's go like this. All right, excellent. Good job, me. All right, so now let's highlight this last one, okay? Method and the position, right? God, that looks horrible. Let's see if I can erase that. I'll go back to yellow. Yellow seems to work out. All right. So what are we noticing here? We're noticing you got a pretty big F score, right? Yeah, the F score looks bigger. It's much more bigger than this one and this one. So you're also looking at the significance. Now what do we see here? Right? So the method, whether you take all the players and train them per the different method, didn't really result in a good significance. You take the position players and train them in their position alone, that doesn't exactly help them either. But then you take the method and the position, and then you train them in both modalities. You got two groups working different modalities here, and you can see that there's a pretty strong significance that relates to having a good significance. So again, F, right, and this is my normal distribution, not the scale, right, closer to 0 or the mean, or this kind of funky looking U, right? The micro or whatever. You got this one, the one that we want, the significance. We got it way out here. So just trying to tie it all together, everything that we've kind of looked over from descriptive statistics in the last section of material. So this is the last test that the book really kind of goes over, and I hope that it helps. I hope that it, you know, shines a light on the material that we're trying to read, because sometimes when we're reading the stuff, it's not exactly the clearest thing to read. And then YouTube, there's not a whole lot of videos or instruction that's out there that shows us as exercise scientists how to really relate this material. So I hope that it does. I hope this helped, and I look forward to seeing you guys in the near future. All right.